Yes, good morning to all of you. Listen, today we'll start with the problems related to the relativity concept, that is length contraction, velocity addition theorem, time dilation, E is equal to mc squared, using that concept, mass and energy are interconvertible, and all these concepts, including the momentum theorem. Okay, we are supposed to solve some problems. Get ready with the problems. Problems are also there for your final exam as well as for your IA. Okay. June first week you will be having, most probably not July 1st. July 1st you will be having the theory IA test. So get ready with the concepts. Relativity, everything you have to read it, including the problems. Relativity problems, first chapter problems that I am starting now. Okay, write the first question. Write the first problem. Get ready with your calculator, scientific calculators, I said. Okay, side by you have to keep the scientific calculator. Take sheet of paper, take the pen, start to write. A meter rule moves. Problem number 1. A meter rule. Quickly you have to write. Moves. A meter rule moves past an observer on the earth with a velocity of 2.5 10 to the power 8 meter per second along the direction of its length. Direction of its length. What is its apparent length? With respect to the observer. With respect to the observer. With respect to the observer. This is the question. Okay. Right? Length contraction problem. This belongs to the length contraction. There is a rod. He has given that a meter rule, which is moving with respect to an observer on the earth with a velocity this much. Along the direction of its length, what is its apparent length? What is its apparent length? Very simple question, very simple question. Let me write the data first. A meter rule must be having a meter scale. Meter rule means it is a meter scale whose length is equal to 1 meter. Whose length is equal to 1 meter. So original length, proper length of the body is equal to 1 meter, which is moving with a velocity of this, which is moving with a velocity 2.5 10 to the power 8 meter per second along its length. What is its apparent length? Okay, what is its apparent length? Length is equal to how much? That is to be determined. Okay, so formula L is equal to L naught into square root of 1 minus V square divided by C square. Substitution calculation, you are supposed to do it. Of course, C value, you know that. C value 3 into 10 to the power 8 meter per second. Shall I Do the substitution calculation also. You are having scientific calculator now. Do the substitution, do the calculation by yourself, quickly, quickly. Everything I have given except substitution and calculation. Do the calculation. You can unmute and you can answer the question. What is the last answer? Or you can type and you can give me the answer. Zero 0.7531 Pranav. It's wrong. 0.4082, it's wrong. Rashmi, it's wrong. Sabha, 0.55 meter. Sharat, it's very good answer. Correct answer. Sharat. Sandhya, it's correct. 0.5527. 0.5527. Congratulations. Yes, right. Correct answer. Stephen. This answer 0.5527. So many meters. This is the answer. Okay, finished. Right, the next question. Calculation part, you are supposed to learn it. You are not in first PUC or SSLC. No. You have to learn the substitution. Just you have to do the substitution here, and you don't have the ordinary calculator. You are having scientific calculator. You can use the scientific calculator here. Very easy for the calculation. Very easy. Or shall I do it? You tell me that. Shall I do the calculation also? If you didn't get the answer, I will do it. Yes, I am asking you. Let us not waste the time. Shall I do the calculation? Shall I show it? Or all of you got the answer? Okay, problem number 2. A rod 1 meter long. A rod 1 meter long is moving along its length with a velocity (0.6 c). Where c is the velocity of light in air or vacuum medium. Full stop. Calculate its length. Calculate its length as it appears to an observer Question number 1. On the earth, question number 2. moving with the rod itself. Moving with the rod itself. Moving with the rod itself. First, let us write the data first. Read the question, whatever the concepts are given, you think and write the data. A rod of 1 meter long is moving along its length with a velocity something. So, he has given a rod whose length is given, velocity is given. Calculate its length. Easy. A rod of 1 meter long, L naught is equal to 1 meter. Original length, which is moving with a velocity of v 0.6 times c. 0.6 times c. Right. Of course, c value is the known thing. If you want, you can substitute the c value if you want. Calculate its length as it appears to an observer on the earth and moving with the rod itself. First, I will write number 2 question answer. As the rod is moving along with a person also moving along with the rod, and if he is observing that one, then the length could not be able to change. It remains as it is. Okay. So for an observer, moving with the rod itself, the length remains same. Therefore, answer length is equal to 1 meter only. No change in it. But for the first question, we had to calculate L is equal to how much? L naught into square root of 1 minus v square divided by c square. Now we have to make the substitution. L is equal to L naught value 1 v square 0.6 times c divided by c square, that is equal to 1 as it is, that is square root of 1 minus 0.6 square into c square divided by c square get cancelled. Therefore, L is equal to square root of 1 minus, this is 0.6 square, 0.36. How much? You tell me the answer. Somebody has shown the answer in the beginning itself. Sandhya, correct. Uma, Rashmi, Stephen, correct answer. Yes, right. 0.8 meter. Okay, slightly the problem will becoming more and more complicated, slightly. So carefully you had to think and you had to answer. Problem number 3. With what velocity should a spaceship fly so that every day spent on it spent on it may corresponds to 3 days on the Earth's surface. On the Earth's surface. Why, Alina, so late? Yes, right. 3 days on the Earth's surface. Now, what are the data are given? Carefully, you have to read it and answer it. With what velocity? With what velocity? Right. With what velocity should a spaceship fly so that every day spent on it may corresponds to 3 days on the Earth's surface? So think about the question. Let us write the data. With what velocity? With what velocity? With what velocity should a spaceship must fly so that every day spent on it may corresponds to 3 days on the Earth's surface? I hope you understood. A person who is spending 1 day in the spaceship is equal to that of 3 days in Earth's surface. So therefore, T naught is equal to 1 day. T is equal to 3 days. Then V is equal to how much? What is the velocity of the spaceship? So therefore, a person who is there in the spaceship, a person who is present on the Earth's surface, if you are comparing them, on the Earth's surface, the age of the person is go on increases very easily, very quickly. In the case of the spaceship, the person age is going to get slowly it is increases because of this fact. Yes, right. Which is the concern formula? Time dilation. This problem related to time dilation. Formula T is, don't get confused with the previous and this one. As far formula difference is there, T is equal to T naught divided by square root of 1 minus V square divided by C square. Okay, time dilation formula. Yes, we had to do the substitution and we had to do the calculation. Are you going to do it? I will give you 2 minutes time. Do it slowly, no problem. 2 minutes is sufficiently enough to do this calculation. After 2 minutes, I will start to work it out. Of course, C value, you know that. Got the answer? Kirtana, got the answer? Sharat, have you got the answer? Vinuta, Sania, nobody has done the answer. Yes, look at the calculation part now. Just observe here. I will do it. I will do it. No problem. Just you see here. Very easy concept. No problem. So here, shall I write t divided by t naught here? 2 square 2. What is that answer? Okay. So t divided by t naught 1 divided by root of 1 minus v square divided by c square. Right. T value 3, t naught value 1 is equal to 1 divided by root of 1 minus v square divided by c square. Correct? I will take the reciprocal on both the sides. Therefore, 1 by 3 is equal to how much? Square root of 1 minus v square divided by c square is equal to 1 by 3. Taking the reciprocal on both the sides. Squaring on both the sides. 1 minus v square divided by c square is equal to 1 by 9. Therefore, v square divided by c square is equal to how much? So, v square by c square is equal to 1 minus, correct now? Okay, minus, this is 1 by 9 minus 1. Therefore, v square divided by c square is equal to 1 minus 1 by 9. I want to write this step in the beginning only. Okay, no problem. So, therefore, v square divided by c square is equal to 8 divided by 9. Right. Therefore, v square by c square is equal to this much. 8 divided by 9. Therefore, v divided by c is equal to root 8 divided by 3. Therefore, v is equal to square root of 8 divided by 3 into c. So, that is equal to root 8. You can see in your calculator, root 8. C value 3 into 10 to the power 8 meter per second. So, v is equal to how much? So many meter per second. That's all. At least now you tell me the answer. Romana hoga. Yes, anybody who has finished? 2.8 10 to the power of 8, right? Yogesh, Sabha, Rashmi, okay. 2.828 10 to the power 8. Okay. Okay, Stephen. Write the next problem then. Write the next question. A wrist watch. Problem number 4. A wristwatch keeps correct time on the earth. If it is owned by the pilot of a spaceship leaving the earth with a constant velocity of 10 to the power 7 meter per second. How many seconds? Does it appear to lose? Does it appear to lose in one day with respect to the observer on the earth? So if the problem is a little bit more complicated, you have to read once, twice, thrice. Understand the problem first. Okay, then we are supposed to take care of the consent formula, substitution, calculation, before that writing the data, everything. But most of the cases that I have observed, without understanding the problem, the student, they will start to answer the problem. So you should not do that. Don't touch the problem unless you understood what the problem it says. What is the meaning of the problem? First you read it. First time you read it, for about another 50% of the question you can understand. Second time you read it, 90% you can. Third time also you read it, so that 100% sure you are going to understand what the question states. Then we can go for how to answer the problem. Okay, this is the method that we are supposed to follow. Yes, a wristwatch keeps the correct time. The wristwatch keeps the correct time on the earth. If it is owned by a pilot of the spaceship, leaving the earth with a constant velocity of 10 to the power 7 meter per second, leaving with a constant velocity of 10 to the power 7 meter per second. Okay, how many seconds does it appear to lose? So don't forget, how many seconds does it appears to lose? And in one day, how many seconds it is losing with respect to the observer? So therefore, T is equal to 1 day. T naught is equal to how much? Simple question. But only thing is, we are supposed to calculate this T naught in terms of how many seconds it is loses that we are supposed to calculate. How many seconds that loses that we are supposed to calculate. Not this also. Afterwards we can think about that. Okay. Yes, one by one now. But this one we are supposed to calculate in terms of seconds. In terms of seconds we are supposed to calculate. He has given this. but he has given this one in terms of days. So therefore, I will convert this one in the form of 1 day means 24 hours. Okay, afterwards hours can be converted in the form of seconds. Yes, formula. Constant formula, T is equal to T naught square root of 1 minus V square divided by C square. Substitution, this is 24 hours. T naught I suppose to determine square root of 1 minus V 10 to the power 7, C value 3 into 10 to the power 8 meter per second. Therefore, 24 T naught square root of 1, this one 10 to the power of 7 square means 10 to the power of 14, this is 16. So therefore you will be having here it is it get cancelled, you will get a 10 to the power of 2 extra here. 10 to the power of 2 means 100, 3 square means 900, is that right? So 1 divided by 900, this is. See that, just to simplify this. Therefore, T naught is equal to 24 into 1 minus 1 by 900 raised to the power half. You can use the binomial approximation also, no problem. Otherwise, if you are having the scientific calculator, do it. So therefore, T naught is equal to 24 into 1 minus 2. I can take it inside here. Therefore, T naught is equal to 24 into 1 minus this is. Yes, do it. How much you are getting? This is 48 seconds. Sure. This whole thing is how much? This is 48. I'm asking you. Final answer is Yogesh 48. This multiplied by 24 also. I don't know the answer. Just you tell me that. 24 into something. Just to multiply these two, how much you are getting? T naught. Or I supposed to do it? Pranav something, I could not be able to read it. 23.98. The whole last answer 23.98, correct? Is it right? Third decimal point. Dechama, third decimal point. Are you getting third decimal point also? 6, huh? Is it right? 988 or 86? Check it up, check it up. 1 minus, this is 1800. 8669866. Shall I write 7 also? Is it exactly? So many days this is. So many days. Now what we are supposed to do is the difference that we are supposed to calculate. How many in terms of seconds it appears to lose, we are supposed to calculate. Therefore 24, okay, time lost. 24 minus 23.98667. So many days. This one you had to convert in the form of seconds. I'm sorry, this is hours. Is it hours? 24 hours, I'm sorry. So this is in terms of hours. Now convert in the form of seconds. That one multiplied by, okay, 60 seconds. All right. Yes, do it. Otherwise, here only we can consider 24. 24 minus 24 into that term 24 minus something else is there now. That itself is the answer. Okay, how much we are getting here? 47.988 seconds. Okay, see that? Look at the answer. Have understood? You see that? This is a question. I told you already, slightly the question strength is go on increases. Carefully you have to think and you have to answer. Okay, problem number 5. This is in terms of hours, difference hours. Convert in the form of minute, then convert in the form of seconds. Okay. Okay, problem number 5. How fast would a rocket have to go relative to an observer for its length to be contracted to 99% of its length at rest. This is the question. Okay, think about the question first. How fast would a rocket have to go relative to an observer for its length to be contracted to 99% of its length at rest? Okay, shall I give you 2-3 minutes time to solve this problem by your side? You do it. Let us see. I will give you 2.5 minutes time will be given. Afterwards, I will start. Do it fast. Okay, finished? Got the answer? Shall I start now? 10 minutes more. So I will finish it off. Just to see here. How fast would a rocket have to go? How fast would a rocket have to go means velocities that we are supposed to do it. Relative to an observer for its length to be contracted. For its length to be contracted. So length to be contracted, how much? 99% of the original length. 99% of the original length. So meaning L is equal to 99% of original length. So therefore, L is equal to 0.99 L naught. Okay. Yes. If you know all these things, then easily we can find out. So formula, L is equal to L naught into square root of 1 minus V square divided by C square. Therefore, squaring on both the sides, L square is equal to L naught square into 1 minus V square divided by C square. Squaring on both the sides. Therefore, 1 minus V square divided by C square is equal to L square divided by L naught square. Therefore, minus V square divided by C square is equal to L square by L naught square minus 1. Therefore, V square divided by C square without that negative sign, if I want to write 1 minus L square divided by L naught square. Clear? Therefore, V square is equal to C square into 1 minus L square divided by L naught square. That is equal to C square 1 minus this one. How much? L is equal to 0.99. That is L naught, that square, divided by L naught square. So therefore that is equal to C square 1 minus L naught square get cancelled, 0.99 square. So that is equal to V square is equal to this. Therefore V is equal to, this is V square. V is equal to, if you are taking out the square root here, we can write how much? This is C 1 minus 0.99 whole square, that is root of that. Root of that we are supposed to take 1 minus 0.99 square. And to do this calculation, so this is 3 into 10 to the power 8. To calculate this, whatever you are getting, you have to write it here, and multiplication you have to show it. You will get the answer here. So many meter per second. Quickly, if you are doing the calculation, one more problem also we can cover it. Still 7 minutes time is there. We can. Vinay, got the answer? Zero point 10 to the power, Vinay, you didn't get it. 4 point. Okay, right, Rashmi, it's right. 4.24. Third decimal point, whatever you are getting, you write it. 10 to the power 7. Otherwise, 0.24. 0.42 you can write. 0.424 10 to the power 8. You can write like this also, no problem. Meter per second. Yes, last problem, let us solve it. Problem number 6. Quickly you solve it. Quickly you write it. Problem number 6. A clock in a spaceship. A clock in a spaceship emits signals at intervals of 1 second as observed by an astronaut in the spaceship. In the spaceship. Full stop. If the spaceship travels if the spaceship travels with a speed of 3 into 10 to the power 7 meter per second, what is the interval between the successive signals? Interval between the successive signals as seen by an observer at the control center. At the control center on the ground. On the ground. That is a question. Shall I give it for the homework just to see that? If you didn't get the answer, next class I will solve it. That's okay. I will solve it in the next class. You try it. You try it at home. Okay. Yes, write all these concepts properly. Study well at home. Problems are there for your internal assessment test. Today evening at 4:30, again we are meeting. I want to discuss something. For that purpose, again we are meeting at 4:30. All of you are supposed to be. How many they are absent? Just to inform them also. I will send the email at around about 2:30 or 1:30. I will send it. Okay. But 4:30 we are going to meet it. Okay. We are meeting again at 4:30 to discuss some other concepts. It's not a class. It's not a class. Okay.